What are the prerequisites for machine learning? Introduction. With these vastly growing technologies of machine learning and artificial intelligence, every engineer and every computer science enthusiast would have wanted to become a machine learning engineer at some point in their lives. Now that you are here, you might as well have had the thought of how to become a machine learning engineer. As clear as it already is, machine learning is one of the most highly practiced and in-demand technologies of our time and for the future. For all the beginners here, it is very important that you clearly understand the importance of the prerequisites for practicing machine learning. Before we get into the video, press the subscribe button by activating the bell icon to get notification. This blog discusses some of the key prerequisites for machine learning, together with the advantages and disadvantages of some of the most popular programming languages for the purpose. Necessary prerequisites for machine learning. To get professionally certified with a Machine Learning Master's Certification program, candidates do not necessarily need to have skills in prior practices of the field or whatsoever. Since the only base factor to practice in this domain is to have a keen and skeptic idea on using programming languages, the key factor that aids better understanding is to first understand the basic concept that structures the algorithms. To get started with machine learning, one must be familiar with the following concepts that drive a better understanding of designing machine learning algorithms. Calculus is the base when it comes to writing algorithms for learning paths. The part where deep learning comes into play is where integral calculus comes into play. This allows the machine to understand the role of the algorithm for the statistical features supporting machine learning features. The training of algorithms makes use of multivariate calculus. You should study and apply the crucial ideas of derivatives, divergence, curvature, and quadratic approximations. Statistics are something that is used to obtain an outcome from a result. The data fed to the machine is converted into understandable information that is understood by the machine. Statics help machines learn the concept and compare the values and results of different data sets. Algorithms designed using statistics help obtain important information from samples of raw data instead of making use of the entire dataset. Probability, as you may already know, helps in predicting the occurrence of an event. As for designing an algorithm for machine learning, probability would be the foundation since it allows you to reason about the likelihood of an event happening or not happening. Machine learning algorithms are designed using probability to ensure the application of a deep understanding. This will also aid in designing learning algorithms that are capable of making decisions. Linear algebra is another important prerequisite for machine learning processing. Here, linear algebra helps in providing a better processing environment for machine learning algorithms when they deal with graphical information like images, videos, and audio data. Linear algebra also allows machine learning algorithms to understand and unlock the meaning of high-dimensional data sets. The following are a few concepts of linear algebra that one must learn about to practice machine learning and to understand how machine learning works. Symmetric matrix, matrix multiplication, machine learning prediction, principal component analysis, PCA. Programming languages are a very essential concept to first practice before starting to learn machine learning. As the machine learning algorithms are executed in code, knowledge of programming languages like Python or R serves as a foundation. It is advisable to acquire a minimum of one programming language because it will significantly improve your grasp of the internal dynamics of machine learning. You should master a programming language that will make it simple to build machine learning algorithms, though. Python. Python is a popular language used in machine learning, particularly amongst novices, because of its simple syntax, constructed features, and robust package support. It includes the most supported libraries, with which the Python Package Index, PyPI, gives you access to more than 200,000 packages. Additionally, the Python learning community is quite supportive. With the aid of certain tools, machine learning with Python becomes more applicable around foundational concepts. Python will teach you NumPy for performing mathematical computations, TensorFlow for a deep learning framework, the deep learning software PyTorch, computer vision with OpenCV and glib, classifiers and regression techniques with scikit-learn. But Python struggles with multithreading and is comparatively slower than other languages. R. As popular as Python is, R is also a prerequisite for AI and machine learning. Many machine learning applications use R as their implementation language. Graphs and respectable library support are features of the program. Regression and classification-based procedures with kernlab and Caret. Data Explorer for analyzing data. BART and SuperML. Workflows for machine learning using MLR3. Data visualization with Plotly and GPLoot. Unlike Python, R can be challenging for beginners and is also comparatively slower than C++. C++. Games and complex systems are known to use C++ very frequently because of its property of accessibility. The preferred programming language for creating libraries is Java, which helps develop a solid understanding of logic construction. If you're the person who's looking for online course, then you're at the right place. Check link in the description for more information.